Hello students, in this class we will learn how we can find the sum of the terms of an AP. Okay, so let us study how we can find the sum of the terms of an AP. Suppose we have to find the sum of the series one plus 2 plus 3 plus 4 plus continuing plus 97, 98, 99 plus 100. Okay. Suppose we have to find the sum of this series 1 plus 2 plus 3 plus 4 plus continuing plus 97 plus 98 plus 99 plus 100. Now, if we follow the value of this series, then this is an AP series because its any term minus its previous term always gives the fixed value. Like 2 minus 1 will give 1, 3 minus 2 will give 1, 4 minus 3 will give 1. Similarly, 98 minus 97 will give 1. 99 minus 98 will give 1. 100 minus 99 will give 1. Okay. So, this is an AP series and how we can find the sum of the terms of this series. Now, if we let S equals to 1 plus 2 plus 3 plus 4 plus continuing plus 97 plus 98 plus 99 plus 100. So, first of all, we let the sum of this series as S. So, again we can write S in this way 100 plus 99 plus 98 plus 97 plus continuing plus 4 plus 3 plus 2 plus 1. That is, in here S is first of all S is in ascending form, and in the second case we can also write S by the descending form of order terms. We can say this is relation 1 and this is relation 2. Adding 1 and 2, we get S plus S will give 2S. This as a pair, this is another pair, this is another pair, and by following this we will get 99 plus 2 another pair, 100 plus 1 another pair, and these are also the pairs. We will get 1 plus 100 is equals to 101. 2 plus 99 will give 101. 4 plus 97 will give 101. Continuing plus 101 plus 101. Okay. That is the pair, the addition of each pair of values will give 101. So, this implies 2S equals to 100 into 101 because there are 100 terms in S. That is why we will get 100 pairs of terms. So that is why 101 plus 101 plus 101, when added we will get 100 into 101. Okay, like as 5 plus 5 plus 5 will give 3 into 5. By following this concept, we can write 2s equals to 100 into 101. So this will give s equals to 100 into 101 by 2. So we can write s equals to 100 into 101 as 100 plus 1 whole divided by 2. Okay. So sum of this series of values, that is 1 plus 2 plus 3 plus 4 plus continuing plus 97 plus 98 plus 99 plus 100 will give s into 100 will give 100 into 100 plus 1 whole divided by 2. Now following this method, if there is an AP, now this method we can find the sum of s, the sum of a plus d, a plus 2d plus continuing plus l minus 2d, l minus d plus l, where l is the last term. If there is in numbers of terms, then an is equals to l. That means if there are n terms, then we can say the value of last term is equals to n, which is equals to l. Okay, so this series also an AP series, where the first term a1 is a and the common difference is d. Okay, so similar with the previous, let s equals to a plus d plus a plus 2d plus continuing plus l minus 2d plus l minus d plus l. Again, we can write s by following the previous method, that is by following the descending form of terms, that is s equals to l minus d, l plus l minus d plus l minus 2d plus continuing plus a plus 2d plus a plus d plus a. This as capital 1 is capital 2. Adding 1 and 2, we get s plus s will give 2s and These are the pairs. These are also pairs, form pairs. So these pairs, when added, we get A plus L, A plus L, A plus L. Since there are n terms, because according to this concept, we consider L is L as the last term and the value of last term is n, where n represents number of terms. So we can say there are n numbers of terms. That is why this A plus L added up to n times. So addition of this A plus L up to n times, we get n into A plus L, which will give S equals to n by 2 into A plus L. So this represents the sum of n terms which are in AP, where first term equals to A1, nth term equals to n equals to L. Okay. The another form of S can be written as S equals to n by 2 into A plus L means A plus n minus 1 into D, where D represents common difference and L equals to An equals to A plus n minus 1 into D. So this implies S equals to n by 2 into 2A plus n minus 1 into D. Okay. So this is the another form of summation of all the of n numbers of terms of an AP. Okay. So these are two distinct forms. We can use this form when the first term and the last term of an AP, also its number of terms is known. Okay. When the first term, number of terms and common difference of an AP are known, then we can use this second form of summation. Okay. So now we choose a problem. Which problem help us to understand how we can find the sum of terms of an AP. Okay. So in the problem, the sum of first 6 terms of an AP is given, which is 42, and the ratio of its 10th term to for 30th term is also given, which is 1:3. That means for an AP, it is given that the sum of its first 6 term is 42 and the ratio of its 10th term to 30th term is 1:3. We have to find the first term and the 13th term of that AP. Okay. Solution. Given. Also, we can write the sum of in terms of an AP as Sn. So, Sn represents sum of in terms of an AP. So, S6, sum of first 6 terms of an AP is 42 and ratio of its 10th term to 30th term, that is A10 is to A30 equals to 1:3. That is A10 by A30 equals to 1/3. Okay. So, to find the sum of any number of terms of an AP, first of all we have to know the first term and the common difference of that AP. So, that is why let first term and the common difference of the AP be A and D respectively. So, therefore, S6 equals to 42 imply 6 by 2 into 2A plus 6 minus 1 into D equals to 42. By following this formula, Sn equals to n by 2 into 2A plus n minus 1 into D. We can write S6 equals to 6 by 2 whole into 2A plus 6 minus 1 into D is equals to 42. We can cancel these 6 and 2. So, this will give 2A plus 5D equals to 42 by 3. 3 14s are 42. So, this will give 2A plus 5D equals to 40. Again, A10 by A30 is equals to 1/3. Imply A10 means A plus 10 minus 1 into D and A30 means A plus 30 minus 1 whole into D equals to 1/3. This will give A plus 9D whole divided by a plus 29d is equals to 1 by 3. Now by cross multiplying, we get a plus 29d into 1 is equals to a plus 9d whole into 3. This will give a plus 29d equals to 3a plus 27d. This will give 29d minus 27d is equals to 3a minus a. This implies 2d equals to 2a. This implies d equals to 2a by 2. Cancelling these two, we get d equals to a. This is relation 1 and this is relation 2. Okay. Putting d equals to a in 1, we get 2a plus 5a equals to 14. This implies 7a equals to 14. This implies a equals to 14 by 7. This implies a equals to 2. From 2, d is also 2 because d equals to a. Okay. So this is the way by which we can find the value of a, that is first term, and the common difference d. Okay. So first term of the AP is 2 and 13th term, that is a13 equals to a plus 13 minus 1 whole into d. This will give a13 equals to a plus 12d. So now putting a and a equals to 2 and d is also 2, we get 2 plus 24. This will give a13 equals to 26. So this is the way by which we can find the first term and the common and the 13th term of an AP by following the formula of summation of all the terms of an AP. Number 2, it is given that sum of n, the ratio of sum of n terms of two different APs is 7n plus 1 is to 4n plus 27. Okay. From this, we have to find the ratio of their mth terms. Okay. So let us study how we can find the ratio of their mth terms. Solution. Given Sn is to S dash n equals to 7n plus 1 is to 4n plus 27, where Sn represents sum of n terms of first AP, and S dash n represents sum of n terms of second AP. Okay. So since there are two different APs, that is why we can represent their sum of n terms by two different ways. That is why we choose Sn represents sum of n terms of first AP, and S dash n represents sum of n terms of second AP. Okay. We have to find AM, we have to find AM is to A dash n, where AM represents mth term of first AP, and A dash m represents mth term of second AP. Okay. Let the first term of the two APs be small a and capital A, and their common differences be small d and capital D, respectively. Okay. So here we choose first term of the two APs be small a and capital A, and their common differences be small d and capital D, respectively. Okay. Because we know to find any term or sum of the terms of an AP, we have to know the first term and the common difference. That is why we let the first term of the two APs and the common differences also of the two APs. Okay. So therefore, Sn is to S dash n equals to 7n plus 1 is to 4n plus 27, imply n by 2 into 2a plus n minus 1 into small d by n by 2 into 2 into capital A plus n minus 1 into capital D equals to 7n plus 1 by 4n plus 27. Cancelling this n by 2, we get 2a plus n minus 1 into small d by whole divided by 2a plus n minus 1 into capital D equals to 7n plus 1 whole divided by 4n plus 27. Okay. So, by the formula of summation of n numbers of terms of an AP, that is, by following this formula, we can write Sn and S dash n as this way. Now, if we take 2 as a common factor from numerator and denominator also, then we will get 2 whole into small a plus n minus 1 whole by 2 into small d whole divided by 2 into capital A plus n small n minus 1 whole divided by 2 into capital D equals to 7n plus 1 whole divided by 4n plus 27. Okay. When we take 2 as the common factor from numerator and denominator, we get this, that is 2 whole into small a plus n minus 1 whole divided by 2 into small d whole divided by 2 whole into capital A plus n minus 1 whole divided by 2 into capital D, that is equals to 7n plus 1 by 4n plus 27. Cancelling these two, we get small a plus n minus 1 whole divided by 2 into small d whole divided by capital A plus n minus 1 whole divided by 2 into capital D equals to 7n plus 1 whole divided by 4n plus 27. Okay. Again, am by a dash m, that is the ratio of their mth terms. That means the ratio of the mth term of first AP and the second AP is equals to a plus m minus 1 whole into small d by capital A plus m minus 1 whole into capital D. Okay, so this is the ratio of their mth terms. Now, if we equal n minus 1 by 2 with m minus 1, then we will get n minus 1 equals to 2m minus 2. This will give n equals to 2m minus 2 plus 1. This will give n equals to 2m minus 1. Okay. Now, if we equalize this n minus 1 whole by 2 with m minus 1, we will get n equals to 2m minus 1. That means from this relation, if we want to find the ratio of their mth terms, then we have to equal these two values, that is n minus 1 whole divided by 2 with m minus 1. So, after equalizing these two values, we get n equals to 2m minus 1. Now, replacing n by 2m minus 1 we get small a plus 2m minus 1 whole divided by 2 into small d by capital A plus 2m minus 1 whole divided by 2 into capital D equals to 7 into 2m minus 1 plus 1 by 4 into 2m minus 1 plus 27. This imply a plus 2m minus 2 whole divided by 2 into small d by capital A plus 2m minus 2 whole divided by 2 into capital D equals to 14m minus 7 plus 1, 8m minus 4 plus 27. This will give a plus, taking 2 as the common factor, we will get 2 into m minus 1 by 2 into small d, capital A plus 2 into m minus 1 whole divided by 2 into capital D equals to 14m minus 6 whole divided by 8m plus 23. Cancelling these two, we get a small a plus m minus 1 into small d by capital A plus m minus 1 into capital D equals to 14m minus 6 whole divided by 8m plus 23. Okay. So this imply am is to a dash m equals to 14m minus 6 is to 8m plus 23. Okay. So this is the way by which we can find the value of the ratio of mth terms of these two different APs. Okay. So this is the important step. This means this step. That means we have to equal this value n minus 1 whole divided by 2 with this value m minus 1, and after equalizing these two value we get n equals to 2m minus 1. Okay, that is why we replace this n by 2m minus 1 in this relation. So after replacing n by 2m minus 1, we get the ratio of mth terms of these two different APs. Okay.